All right. All right. All right. All right. 10 days left. 10 days left. Dang. A lot. It's a lot, a lot, a lot. Let's do this. Let's do Advent of Code Day 15. I feel like I either need to light the back wall up a little bit more or put a backlight on me, especially when I'm wearing a dark shirt. I don't pull off the back wall that much. All right, day 15. What are we? I think let's close this random terminal and let's open Chrome. Let's go to Advent of Code 2021. Are you? There we go. Thank you. Yeah, bye. Okay, so looks like at this point I'm basically kind of like skipping the story and going straight to the input because that seems to be the best way to get through these. But today we have a grid of numbers. So it says it's a risk level. So you see how that's highlighted. It says it's a risk level. And then chitin density. Start in the top left position. Destination is the bottom right. Cannot move diagonally. The number at each position is its risk level. To determine the total risk of an entire path, add up the risk levels of each position you enter. That is, don't count the risk level of your starting position unless you enter it. Leaving it adds no risk to your total. Why would you enter it? Your goal is to find a path with the lowest total risk. In this example, a path with the lowest total risk is highlighted here. So like straight down, then across, and down, across, down, across, down, across, down, across. I wonder if this is not going to go back up. Like it's never going to like go down, over, up, over, down kind of thing. It's one of those things that they don't tell you in the puzzle input. So let's pull in this test case. Drop this in here. Also, what we can do here is we have this parser already sitting in our Advent of Code repo. So our Advent of Code repo, if I can remember, day 11 is the one that I think I was looking at. So input is also a grid. I don't remember if this is which one this is. This is the crabs, I think. So this is going to look like a crab parser. No, this is squids. So for the moment, increment row. I think we need row and puzzle input. So this will get us our grid. We do need to remove the padding. So remember in the squid problem, our parser had a bunch of padding, which was like very useful at the time, but is not going to be useful in this version. So let's get rid of all this extra code that I copied over from day 14. Just real quick. Get zeros in here, comment out this test. Should probably start ignoring this test instead, but okay. So the number that we need is the number 40. So it's the total risk minus the starting position, or not minus the starting position, but it's the total risk of the path. So the weight. This is anywhere we have a squid here. We have to replace with, I guess, a U8 would make sense. But we do have to add them up later. So let's see. Let's do U8. Squid, no squid. We aren't going to need this no squid thing. So let's get rid of that entirely. And then we're going to collect this and do a vec of U8s. And then this. I think we still have to do the one of here because we have to do each individual character. So one of still going to be our parser. We'll bring that in because we don't have it imported right now. Squid energy is not what we need. We don't need that big squid energy. Not today. And then we 2-digit the character. As a U8, which should parse correctly. And then we have basically a row of numbers. Which brings us down here, in which case we need a row of U8s. Actually, this is... We're going to have to find a path through this, right? So maybe constructing the... Maybe constructing this 2D array isn't worth it. But we do get an indexed iter off of it, so I'm not too worried about it. Let's get rid of these paddings, right? So v.iter.cloned. We don't need v.iter anymore, which means this whole chain doesn't exist anymore. It's just going to be data into iter, flatten, collect, vec8. And then we don't need this +2 anymore, so we get the from shape vec. And the return value here. I don't know why the return value is complaining. Why is the return value complaining? It's because we don't have these. Do a cargo build. And let Rust tell us why. Expected array base found tuple. So we're only returning the whole thing. That's why. Map. But really, this isn't going to be a 2D array. This is going to be, I think because we need to iterate over everything so much, we are going to do pet graph today. I'm getting rid of a bunch of stuff from the imports, including the file, right? So this should compile now. If we cargo test, it'll fail because we haven't done our tests yet. So we have a left value of 40 and a right value of 0, which means that at least our parser is running. We don't need this v value anymore. So if we debug map here, we should just see the grid of numbers. We'll just do a visual confirmation on that. So yeah, grid of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That seems right. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I think that we also have code to convert this into pet graph. I don't remember which day we used pet graph on though. So I'm just going to take a quick peek through this because we already have the construction code. This is a bunch of steps. That's not that. Day 12 was... I should include the descriptions in these. What's the input here? The input here is the graph. I think this is the graph. Lib. Oh, this might have been the one we did manually. This is the one we did manually. This doesn't have pet graph in it. So anyway, the whole goal here is to set up basically a graph of nodes and then find a path through those nodes that is the shortest. Pet graph, of course, being an easy way for us to pull in a shortest path algorithm, because pet graph has a bunch of algorithms for doing that. Is this pet graph? Here we go, pet graph. So let's take a look at graph map wherever we did that construction. This is a bunch of inserts. We did nodes. I don't know that we want... Actually, I think we can use graph map. So this is insert and this is node. And we'll pull in those, and then this is from shapevec. So our puzzle here, our puzzle input in this day's problem also did the same thing. And then we did indexed iter and we did inserts. Perfect. Let's do that. That sounds like exactly what we need. We basically need this graph to exist, right? And I don't think we need the points. I think we just need the weights. So I think instead of node, we can use U8 here. That's U9. There is no such thing as a U9. And then undirected. And this is going to be a U8. I guess, do we need to get the... We do need to get the values around it, actually, now that I think about it. So we do need the positions here. We do need node as our data type. Let me back out this change. We still are going to want these positions because it's going to indicate which spot in the graph is weighted a particular weight. I guess it doesn't really matter to us. Now that I think about it, if we don't use graph map, right? So let's look at pecgraph, right? Pecgraph is a graphing library in Rust. It basically gives us a bunch of different graph types that we can construct. And then we get to use algorithms like Dijkstra. I don't know how to pronounce their name. But this algorithm is like a shortest path algorithm from A to B. So we have some options here. Graph map is the one that we were using. We have tried to use matrix graph in the past, and it didn't work for our last problem, but it might work for this one. So the nice part about graph map is that, or what we were using it for the other day, is that this node type on the graph map is used as the ID of the node. So if we pass in a node with the same values as in what we had over here, so if we pass in a node that's at the same point without the same weight, then it's the same node in the graph. But for us, we only have a bunch of weights basically. We do need to choose a starting point though. So we either need to remember the starting point when we insert it or remember the ending point if we don't use these node types. I think we need to do that anyway. So I think we'll be okay. So we're going to have an undirected graph, and that's what these generics are. So it's like the node type, the edge type, and the whether it's directed or undirected points from node to node. In our case, we have undirected graph. We have a node type of whatever we want, which could just be U8s. And then we have an edge type of probably the weight between. So in this case, we have this insert function, right? Did I pull in graph map? No, I forgot to do that because I undid it before. Okay, so this isn't a height map anymore. This is like a Chiton map or something. Oh, I didn't pull in the process part 1. That's why this is confusing. Again, we already wrote a bunch of this like insert stuff into a graph code. So I'm just pulling that back out of the solution that we wrote previously because it doesn't super make sense for me to write it from scratch again since we already wrote it. Get rid of that. I'm gonna make these both map. I'm gonna make all of these map actually. Sum value equals maybe value index iter. Why is that sum value? Oh, right, because we had sums wrapping our previous types, I believe. So in our previous algorithm, what we had is a bunch of padding around our graph, or around our grid, basically. So some of the values were non-values. We are not going to have that here, so this is just going to be value. And we'll be able to get rid of this whole, like, if block here. And then let's check Rust Analyzer. Let's check MA value. Why did I mess that up? Okay. And then this map is also having an issue for some reason. It's an array to option U8. It's not an option U8. These are all going to be U8s, so they're just going to be there. And this is not going to be some weight. So what we're seeing here is basically the refactoring power of having Rust's type system. It's going through and telling me that, hey, you pulled in code and then you changed the types that you were working with. Thus, all of this other code that you've written needs to be changed as well, because before we were wrapping everything in some types because we had some nodes that existed and some that didn't. But in this case, we aren't. So we have to remove all of that like extra wrapping ceremony code. And the Rust compiler knows that and is telling us that. Okay. So what this does is it adds a node and it adds an edge. I think in this case, the edge is going to have a weight. So the edge is going to be the weight here. Like moving from, say, 1 to 3 costs 3. Moving from 3 to 1 costs 1 is what I read in the problem statement. If it doesn't, then we can always adjust the risk level later. But we still need this graph and to be able to traverse it. So the weight, I thought that was right. What are we failing on here? Expected unit found U8. Oh, right, because we constructed this with an edge type of unit, but we need to construct it with an edge type of U8. So where are we constructing the map here? Here, this is going to be U8 for our edge type. Again, these are type arguments. So we have a graph map and we're saying the nodes are of type node, which is a custom struct that we made. The similarity in name between what the node type is called and what node is called is arbitrary. It doesn't need to be called that. The edge type or the edge weight is a U8 for us. And then the graph is undirected. So we pass in that weight, we pass in that other stuff, and attempted to subtract with overflow. Interesting. Okay, so we're going to have to put in a couple blockers here, because when we had the padding and we were iterating over everything, basically the padding was protecting us from overflowing. But in this case, we're not protected from overflowing. So if we were at a 0.00, right, and we wanted to go and check the neighbors, which is left, right, top, bottom, we would have hit a non-value above, but it would have been like a none as an option type instead of a out of bounds index. So we're doing indexed iter here. I wonder if there's a ND array Rust. I wonder if there's like a neighbors here. There's definitely a Windows. Windows is not really what we want at the moment. I guess it could be, right? The indexed iter, we could Windows over this theoretically. I think we would have to add the padding back in, and I'm not going to do that. Let's go with the iter crate. So we have axes iter, exact chunks iter, lanes iter. So I think we just have to go with the arbitrary access here. But that means that when we do this, specifically the subtractions, we have to be careful. So can we do as I size here? That would be awkward. Let's do if point.0 equals 0, because that'll protect us from this. Then, well, if it not equals 0, then we're good, right? So then we do the insert, and this insert returns unit. So that's why we can do the if without an else, because we're not returning anything from this. And then if point.1 not equals 0, then we can continue with the insert here. So that should fix our out of bounds errors, if I did that correctly. So theoretically, at the bottom here, we have a graph now. Yeah, there we go. A graph, a bunch of nodes. All right. So let's just do, I guess, I don't see the edges in this debug. That's interesting. Let's just try to call the algorithm, right? Let's just try to get it done and see what it does. And when we figure out it won't work, we will figure out what we need to do instead. So the shortest path algorithm takes a graph, takes a start node and an end node, which is apparently optional. Interesting. But it has to be the node ID. And then the edge cost function. The way this works is basically we try to get from A to B, and the edges cost something. So the edges cost whatever the next node is going to be. I think I set that up correctly. That's actually not true. And actually, when we're doing this insertion, I don't know that we need to insert both of them. So if we index iter, we start at the top, and we only need to do the right and the bottom, right? So we say, I think it's YX. So we're gonna keep that one and get rid of that one because we're never gonna need to insert the top, I think. Right? If we insert the right and the bottom as edges on the current and it's undirected, then we should be able to go back and forth between them. So this is down and this is left. So we only really need to do these two. So yeah, 0.98 or 89 as we would read it. Looks like it's connected to 7999 and 88, which sounds right because it sounds like it's down on the bottom. So that seems good to me. Does this graph let us call? No, we have to call it with the whole function. Okay, so we do. Because my spelling would be horrible. We do this, and we need to import it. So hopefully Rust Analyzer will be able to do this for us. We're going to pass graph in here. I think it has to be a reference to the graph. What's the problem there? Yeah, expected 4 arguments. I know it expected 4 arguments. So we need the start and the end nodes. Maybe we do this. Maybe we do... I guess we can just grab this index iter again, right? So if we do this and we do let it equals this, this is going to have to be mutable because we're going to manually rotate through the iteration right now. So it.next will be let first or let start equals this, and let end equals it.last. We're going to unwrap these because they have to be there. If they aren't there, then we're in trouble, like deep trouble. So then we do start sum end, and this is our edge weight function. So what does this get in terms of, it looks like it gets an edge ref. An edge ref is probably just the edge weight. So probably we want to return, oh, start end, right. We need to do the node construction for those. So it's going to be like this. And this it.next value is going to be, oh, actually, let's do it slightly differently. Let's do this. And this is next dot 0, right? Because this is going to be a tuple. And this is next dot, yeah, right? I messed something up here. What is the value of, we get a tuple of usize, and a u8. So this is node, this is going to be node.0, this is going to be node.1. And this can't be let node, this is going to be start. And then we need to do this again, but not next. We need to do last here, and this is going to be last it. This is also not using the right variable names, so we're going to update that. We'll update that in both places. Last it. That is going to be start and end. And why is that going to be a problem? Because these take references? No, it's not because they take references. What is the... Expected an implementer of trait into edges. Trait bound graph map node U8 undirected is, so we don't have into edges for this. Interesting. This is going to be end. It's really interesting. Wow. Okay, so what is into edges then? The formal iterates. So dot edges. Do we need to... Oh, wow. I think we need to generate this ourselves? That's weird, right? Do we need to write this trait implementation ourselves? I mean, like, okay, so we can, right? We already have that information, but it's just interesting to me that that would be the case. because we already inserted the edges, right? So why would we need to implement into edges for node? It says consider borrowing here. Maybe it's only implemented on references. that is unfortunate in terms of that error message. That error message is not great. It's like it's suggesting me both to add and remove the borrow. So the trait bound graph map node U8 undirected into edges is not satisfied. So does graph map not implement into edges? That would be weird, right? Into edges for a reference to, so lifetime A, NA, EA. So do these need to be then all references? Is that the issue? Is the issue that we're not matching this on everything basically? And then edge is node U8. And then we do edge dot two, and not edge over two. Edge over two is not what we want. Edge dot two. And it's the value. Okay, that ran. So basically we just weren't, so the trait into edges is implemented for what probably is a reference to the graph, a start node and an end node that implement equality and hashing. So it was a little confusing. That the error message was a little confusing. But the way to think about trait implementations that don't exist for given types is, do I have the right types first and foremost? Oh, you know what I realized I just was doing? I was like, nobody's chatting today. That's so weird. I was looking at the empty popped out chat. Oh, so I just missed everything y'all said. Sorry. Hey, Commander. Hey, Nikki. Hey, Xander. Hey, Derek. Hey, hello, everybody. Thank you for coming. Wow. Respirator parser this time is very easy. Yes. So we took the parser from the other day. We actually already wrote this parser. So the flashing fishes, only poisons that are walked over are counted. So not counted at start. Yep. There's no 0 in and will not. You generated a B tree map with XY as key. And then did Dijkstra or A star. Yep. Both of those would work. That was amazing. I had that experience refactoring my AOC solver code. The compiler went, cool, but the place you used this public function is now wrong. Yep. Isn't it only applicable to directed graphs? I have no idea. It looks like that is not true. Do you need to cast graph map to graph? I don't think so. I think the types were just wrong. It looks like maybe graph hasn't implemented, so you need to borrow at graph. Yes. Okay. We're caught up on chat. Whoops, that's my bad. I was looking at the the empty space where chat should have been, and the popped out chat was behind the Chrome window. Okay, so basically we get what I think is a node and the cost, maybe. Interesting. This is giving us back, I think, the weight to every point in the graph. Is that what this is returning? Let's go look at the algorithm. Monk. Okay, graph, start, goal, edge cost. Shortest path from start to every reachable node. Oh, that is every reachable node. Wait, so why do we provide goal then? Oh, if goal is not none, then the algorithm terminates once the goal node's cost is calculated. Okay. So then returns a hash map that maps node ID to path cost. So what we should do here is then we have end, right? So result.get end. And this has to be a reference because, you know, comparisons for the key values. And then this gives us 33, which is absolutely the wrong answer. Away needs a start and an end. Yes. So why do we get 33? Did I calculate this edge cost wrong? Let's do this. Let's do edge.1 because I think that's the destination node. Dot weight instead. And see if we get, yeah, okay. So I was giving it the wrong weight value. I don't know what that third U8 is. And it's not what I thought it was. So that's really interesting. I guess that function changes its type based on what you pass into the graph and stuff, and I just don't understand the algorithm well enough because it doesn't show any nodes in the example. But we have the right answer now. You are not allowed to move diagonally. We are not moving diagonally. The way we constructed the graph is so that every node is connected to the node that's to the right and to the bottom of it. So we don't actually allow our graph to move diagonally. So what is the value that we get here? Is it actually just 40? It's some 40. So result.getEnd.unwrap is our answer. Oh, expected U size found U8. We're gonna have to change that, aren't we? We're gonna, oh, interesting. Okay, so we should make sure that we update the edge weight with like a U32 or something. Because if we do not do that, we were going to overflow when we do this next one, I think. I think U32 is going to be plenty high enough. So we'll go with that. And this will return a U32 now. Found U8. So just changing our number types so that the number that we accumulate into is a larger thing. because the sizes we were using were really small and constrained. They only go to 255, which works for the example, but probably will not work when we go to look at this puzzle input, right? Like this is pretty gigantic. I can easily see this breaking 255 as we go through this. So we just expanded our number types to make sure that we could handle that. So let's do cargo run, bin part 1, and hopefully part 2 is not like absolutely horrible, because part 1 is pretty easy. Hey, my dude. Hey Carlos, how's it going? That is low. Part 2 is 25 times that size. This is not part 2 though. We were submitting the answer for part 1. Okay, now that you know how to find low risk paths in the caves, you can try to find your way out. The entire cave is actually 5 times larger in both dimensions than you thought. The area you originally scanned is just one tile in a 5x5 tile area that forms the full map. Your original map tile repeats to the right and downward. Each time the tile repeats to the right or downward, all of its risk levels are 1 higher than the tile immediately up or to the left of it. However, risk levels above 9 wrap back around to 1. So if your original map had some position with a risk level of 8, then that same position on each of the 25 total titles would be as follows. So all of its risk levels are 1 higher than the tile immediately up or left of it. The area you originally scanned is just one tile in a 5x5 tile area that forms the full map. Your original map tile repeats to the right and downward. Each time the tile repeats to the right or downward, all of its risk levels are 1 level higher than the tile immediately up or to the left of it. So we just add 1. This example is super fucking confusing, because are they saying that we have to do 8 and then replace the values, or just add 1 to the entire tile? Okay, so 116 is 227. Okay, I can deal with that. So depending on the... Why is this 8? Oh, wait, no, this one is the 3. Okay. So can we do this based on x plus y? So 0, 1, 2 plus 2 is 4. So we add 4 there. So I think it's x plus y, right? On the tile indexes. Equipped with the full map, you can now find a path from top left, blah, blah, blah. It's 3:15 for the next test. So we are going to use the same process part 1 value. So I'm just going to copy and paste this and make this process part 2. And the thing that changes here is what? the question in my head is, where do we want to do this duplication? I think we want to do this duplication maybe with ND array. Can we do it that way? Is that going to be easy for us? I guess we could just keep concatenating these, right? So we do need to build up a single vec anyway. We do have all of the outputs here in the single vec. So here, if we do for 0.5 for I in 0.5, for y in 0.5, we need to make sure that we do this in the right order. For column, we'll call this column, right? For tile, column. For row, tile row. So we do across, and then we go down, and we go across, and we go down, and then we go across, right? Wait, is that right? I think these need to be reversed. Tile row, tile column. So we are at 0 for tile row, and we are at 0, 1, 2, 3, 4, 5 for column. And that's just all going to get pushed into data. And let's do match. Well, this isn't, we're not pushing yet. So data dot clone dot iter. So let's do this. Let's do let mute original tile equals data dot clone. So now we have the original row, the original tile dot ender dot map weight plus tile row plus tile call, right? And then it's this, what, mod 9 or mod 10? Mod 10 probably, right? Because we want to do 0 through 9. So it's either 10, which is 0, or it'll be 9. Yeah, okay, I think that's it. It wraps to 1, not 0. Nine wraps to 1. Yep. Thanks for the point out. Appreciate that. So we map over this. So then we can collect and we can extend. So let's do let new tile equals this. We will dot collect into a vec of U8s. And then we will data.extend new tile. I didn't change this, did I? I didn't even copy paste that. F, and I didn't commit the code either. Oh, rip. Okay. I'm going to copy this real quick. And I'm going to back up to before when we had the original code. Make sure that test still works. And then I'm going to paste this and we're going to keep going. Okay. So we have process part 2. This is our puzzle input 2. This doesn't need to be mutable. So we extend with new tile, and then this is n rows times 5, right? And n calls times 5. So data is the vec extended. Let's debug data, which is going to be absolutely massive if we did this correctly, and completely wrong if we did it wrong. Okay, so that's that. It seems correct. Let's do data.length. What is data.length? 2600. We started with 100. Which means we should have 2,500? 2,500 sounds right, right? Because what we're doing here, actually, now that I think about it, is we're starting at 0. So this is just going to be the original title, or tile, needs to be this. And the data needs to be this. And then we stick in the original plus all the others. The second grid is 500 by 500. Yeah, so 2,500. I'm out here trying to figure out how Dijkstra works. Yeah, that's not what I wanted to do on stream today. I feel like that would make a really good like YouTube video. If it was something that I did off stream, figured out, explained in terms with graphics and things like that, rather than it doesn't like investigating algorithms doesn't feel like a good thing to do on stream in that sense. So I didn't want to implement it myself. Okay, but we do have a problem here. There are good videos on YouTube from Numberphile. Yeah, totally not surprised. Not surprised at all. These kinds of algorithms and stuff have been around for so long and have not changed. So, like, there are good resources on them already. Original tile.iter map weight. Yeah, the pathfinding crate was really useful today. Had both a matrix and Dijkstra implementation. That's cool. Okay, so let me check to make sure that our first row here is even the correct set of numbers. If I copy this and I remove all of these little comma spaces, then we should end up with what is the same thing, but is actually not. So I've messed something up. Because it looks like the first value in the second tile, maybe? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, first value in the second tile in our output is wrong. Is that generally true? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wrong. And then all of them are wrong? Oh, you know what I did? I know what I did. This extend is the wrong thing to do. Because what I effectively did is I took the tile and then modified it and then stuck it on the end of that tile, like not next to, if that makes sense. Like it wasn't tile. It was start to beginning tile, start to beginning tile. So it gets pulled in a weird way. So this is not actually what we want to do. So how do I set this up correctly? Maybe I don't flatten. And maybe I just concat. Because once we've done a full row, then we can flatten, and then we can do this. So we have to do a full row first. So that means using outputs. Your plan is to zip matrices together? I guess that is one of the options, right? Because we can map over everything. How do you plan on how do you plan on putting them in the right place? Like, is concat a thing? Concatenates arrays along the given axis. That sound was probably on your end, Nikki. I don't think it was here. First year individual, then the weights plus one, then a plopping sound. I don't think I had a plopping sound. It's possible that it was just me swallowing water or something, but. So this concatenates singular arrays. Map V is what. This page takes so long to load because there's so much documentation. Create a new array based on the new values. So this will create a new array 2. R2 is 0 dot, 1 dot, -1, 2. And map 3 absolute gives you a new array that is 0, 1, 1, 2. Okay, so you can do map V. Map V is really interesting. So azip is the other thing that you were going to use. Because we already have the matrices, right? I feel like azip isn't going to do it though, right? So would concatenate work? Right, so we do, instead of munging this, right? We just comment this out for a second. We do original tile. This times 5 is no longer relevant for the moment anyway. So then we get original tile. And then we have the array. So we do for call, tile call in 0.5 r.mapv v plus 1. Don't forget to skip the adding for 0, 0 paper. Yes and no. New R map V V1. So this is going to give us an array 2, right? Yep. So if we have an array 2 here, then if you have to concatenate, right? How many arrays? It's an array of arrays. Perfect. Right. 0.5 dot map R I. Then we need the same function thing up here. So the match. Match this, mod that. And this. Oh, I didn't do this correctly. I is this map this this. And then this is weight plus I mod 10. This is map V. So this gives us, this is not map V. This is map, but this needs to be iter, right? What am I doing wrong here? Did I... Can't call iter on an ambiguous number type. Is that the same thing for ambiguous number type? Interesting. 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 Right, so there's this. There's concatenate axis. Axis 0. And this is dot collect. What is the original paper, the puzzle input? What do you mean, the tile? This is the original test input that we're working with currently. Mismatch types. What are the mismatch types here? Array base owned repr dim cannot be built from an iterator of type array base owned repr dim usize 2. Array base owned repr u8 dim usize 2. Oh, right. This is a vec. Expected reference found vec. Oh, does that have to actually be an array? Can you only use concatenate on... That's not going to work, is it? The way these types change is really interesting. I want to dig into this library at some point in the future. Yeah, so we can't view this because it's built inside of this function, right? Nice job, Nikki. Nice job. View repr. viewrepper. Value of type array-based viewrepper cannot be built from array-based viewrepper reference to a U8. It's interesting. Is there... Expected reference, found slice. Expected struct viewrepper, found struct owned repper. So the question here that I have is, if we map over this now, we need references to all of the things in row 1 array, row 1 Rs. So I think we do have to iter here. Right? So if we're iterating anyway, then we map over this to create views. And of course, I messed something up. Just a light bit of syntax. Okay, and now we get hopefully something slightly different. We don't want map. Want to collect. The collect is probably too general, right? Value of type slice. Array-based viewrepper cannot be built from array-based viewrepper U8. So if this is a vec of whatever, and then we do the same thing we did before, where we get a slice into it, do we get the right references? Does look like it. This feels like it's going to be painful, just because I'm so unfamiliar with ND array and how it works. The axis is wrong. So then we end up with what is hopefully the right row. We do the thing where we remove all the commas again. Hey, congratulations on implementing the algorithm, Nikki. That's big. So there are still a couple of problems, right? Like this goes up until... This goes pretty far, actually. And then this is supposed to be 2 and not 1. So if we do 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, is that just right at the end? Is that all the way? Is that? I wish VS Code had like a car count. I would just love to know how many characters are here. I bet you there is a VS Code car count. 50. Great. 50 is the number we need. I think the only problem is what, that last one? Like, good. And then the very last 17, 2121. Why are these two wrong? Is the big question. The Rust docs have an example for a binary heap that's literally an example use case is Dijkstra's algorithm. Here's all the code for that, and I made it work for this data shape. Yeah. Nice. That's pretty awesome. Why are we missing these two numbers? Right? 0 to 1, otherwise n. One 7 295 286 is what we need. Why are we missing that? That's strange, right? Like, it's strange that those two would be wrong. Maybe I missed something here. Can we just be really cheeky and do that? So the sequence we are looking for is 555 at the moment. Oh, we aren't going to get 555, actually. We're going to get weight plus I. We only really hit 10. There's an 11. Right? These hit 10 and thus go to 0. Or go to 1, I should say. 1 also goes to 1. So if we add, I think we have to do this addition differently. I bet you that in the places where we have 11s, right? Well, maybe not. Let's do this for a second. Just to get the full line number of the mod 10s. So without the mod 10, well, I think we end up with 11s in exactly the places that we don't want them. Let's find out. I think we do. So this mod 10, if it goes over 10, we have to add one. Basically, I think is the problem here. And we have to add one for every additional 10 it goes over. I don't think that we only go up to 5, so we're only going to hit like 14 or something. But that's the problem. So it's weight plus I mod 10. Let's break this out a little bit just to be a little bit more verbose. Let mod, oh, mod is a, let m equals this. If weight plus I is greater than 10, then m plus 1 plus equals 1. So this is mutable. And then match. Well, after we do the match is when we need to do the plus 1, right? So we match m here. And either way, we add another one, else just res. And this doesn't need to be mutable. So that should give us the correct line number now. That's annoying. It's annoying that it doesn't wrap to 0, because it's just kind of like, oh yeah, you could have used mod, but we didn't want you to. So these numbers are the same now, which means that we can get rid of that. And then we can do the same thing for the rows. This is really, really kind of messy. I'm very interested in map v, and then we just do axis 0, right? And then this is full grid. So just a little bit of array concatenation here. I feel like there's a better way to do this, but maybe there actually isn't. Worth looking into though. Expected array base found enum result. Is concatenate. Oh, you know what we're doing here? Map. This is R. This is not R anymore. This is row 1 R's, which is going to make this awkward. Because I think row 1 R's is a result? Row 1. Row 1 is the result. So this has to succeed. Full grid dot unwrap. A local variable with a similar name exists. Row 1. I can't ever decide whether to use underscores like against the variable name or spaced out from the variable name. We have 2 tests passing now, so all we had to do was reconstruct our grid, and we did that. You know, we did that in maybe an overwrought way. We did it in terms of taking the matrix that we had and expanding it this way, and then expanding it down, which is totally valid. I think the types here get a little bit confusing, So maybe not the best option if you're just starting with Rust. As I accidentally chugged my coffee. Yeah, so maybe not the best option if you're just getting started with Rust. I bet you that there is a slightly better way to do this, to like collect these into the array that we want. But what we end up with works. So after we figure that out, it all runs. So if we run part 2, we end up with 315. Is 315 the right answer? Really? $315? I guess these are pretty small numbers. I just assume these. That's not the right answer. It's too low. That makes sense. So is 315 the test input? Did I run cargo test? No, I ran cargo run bin. Am I cargo running bin on the test input? I am. I'm cargo running bin on the test input. Thank you for asking that question, Derek. I don't, that's not great. Whoops. I feel like I do a lot of that kind of streaming problem where it's like, oh, dang, just lost focus for a second and forgot I did something. I gave an answer to you recently. Come on. Really? There we go. And now we're correct. Okay, so the way we did the problem is we pulled everything into a matrix and then put that matrix into pet graph and ran the formula on it. And that all works. And that means that when our board gets bigger, we still don't have a problem. I assume that the DAT profiles are going to be absolutely failed search. No, I'm going to actually have to remember how to run the command for the DAT stuff. Fine. Bin. So let's do cargo run, release, profile. Well, actually, I guess we don't need to do release, right? Profile, DAT, features, DAT, part 1. Bin part 1. Okay, this is big. I need an A-star algorithm for something. Would be interesting to see this code, how that input for this algo needs to be formatted. A-star is actually a thing here. So it's the same. I don't know what estimate cost is, but it's the same thing. So what is goal? Goal is, so yeah, basically goal is a function. The edge cost is a function, and the estimate cost is a function. So it's the same thing we did already for this. It's pass in a reference to the graph, pass in the start node, and then you get a function about whether it's the goal or not. The edge cost, which we already shown, and then what is the estimate? The function estimate cost should return the estimated cost to the finish for a particular node. For the algorithm to find the actual shortest path, it should be admissible, meaning it should never overestimate the actual cost to get to the nearest goal node. estimate costs must also be non-negative. I mean, that seems like we're going to get the same arguments in here. Dang, I don't know. How do you estimate that? I'm not sure how to write the estimate function, but for the actual arguments that you're passing in, it's going to look almost exactly like our arguments here. So you're going to pass in a reference to the graph, you're going to pass in the start node, and then instead of passing in the end node, you're going to pass in 3 functions that look like this. And each of the functions is going to do something slightly different. But if you have Rust Analyzer and you're doing Rust, you'll be able to see which things and which types you're getting here. So for example, edge here is actually a tuple of node U32. So that's how we know how to get the weight. So if you're actually going to use this library to do that, it's not too far off from the example that we gave here. I'm going to run part 2 while we're talking about this. Yeah. I don't think A-star is that useful for this problem though, like Nikki is saying. So we've got 9 megabytes compared to 300 megabytes. So a lot of work to do in terms of optimization. Let me throw that into the README just so that we have it. I got my new laptop yesterday, y'all. I'm so excited. And let's do a cargo bench just for kicks. I bet you that there's a way to pass a lot of these in as references. We really don't get away from needing to generate the actual data that we need. Actually, yes, because they're all integers. We don't get away from actually needing to generate those integers again. I guess we could technically like reference to something else, but that feels a little weird too. Trade-off with the size is a much faster than a naive Dijkstra implementation because of all the algo work that petgraph has done. Yeah, that makes sense. And it's one of the reasons that I'm using petgraph instead of writing this myself. Yeah. A MacBook with the new M1 things in it? Yeah, 16-inch MacBook Pro. Maxed out, actually. So it's got... ...64 gigs of RAM, an M1 Max chip. And I guess that's really all that's interesting. But I'm going to compile Rust on it later. Like not compile my Rust project, compile Rust, like the compiler. So that'll be really fun. My part 2 bench average is 288 milliseconds on my machine, and mine is definitely naive. Let's find out. We're going to find out in a second how long this takes over here. I think that there's probably, having done this in a way that is not particularly optimized in any way, there's probably a way that we can not replicate a bunch of this data. Yeah, see, mine takes 820 milliseconds. So mine is actually slower than yours, Nikki. And my guess as to why that would be is probably something around allocating all of these vecs, because I'm like collecting and then referencing and then building up more vecs and then referencing and then building up the petgraph stuff. And when we build up the petgraph stuff, We're not using references. We're building up full things. So we have to insert a node for everything. And then we have to build up all the edges to those nodes. So I'm not going to do it on stream, but I might rewrite this to use a lot more references and try to get the heap down off stream. And that will have probably a large effect on runtime, is my guess. Because remember that the libraries we're using are industrial strength, right? They are not optimized for the advent of code problem. And advent of code is a very particular kind of solution. So I'm happy with that. Hour and a half today. Not very... Didn't take us very long to get this far. This is not day, this is day, what, 15? I need an automated script just to update the README in this repo. So yeah, is there anything else you all want to see before we head out? While we have the code up and stuff? Ooh, only searching down to the right makes a huge difference in perf for mine. Yes, that makes sense to me. If we could guarantee that as being true, which I don't know if we can. It seemed from the input in the tests that that might be like a guarantee that we could make, right? Because they don't show it going up ever. I chose to not make that assumption specifically because I didn't know if that was a built-in thing in the generation here, because this only goes down to the right as well. But if that's the case, then we can directed graph to each of these nodes, and it should help a lot too. The full input, oh, the test input, but the full input does? That's something I should do. Just print out the path and then highlight it on a graph like this. I read Advent of Code to draw that conclusion. Yeah. Okay. So that is not a guarantee. It could be possible for the test input, but it doesn't work on the actual input. I'm glad I didn't make that assumption now. I try to not make assumptions like that based on the test input, because the test input is usually insufficient. But yeah. Okay, so we're done for today. Same time tomorrow, as always, and I will catch you in the next one. Same corgi time, same corgi place.